Hello everyone, my name is Nurul Natasha and I am from M1T1. Here is 2 extra questions from Madam Kong about chapter 5. The first question is calculate the density of ammonia in gram per liter at 0.989 atm and 328 Kelvin. So take out all the information given from the question and we'll get the pressure is at 0.989 atm, temperature is 328 Kelvin, and the R is constant gas, so it's always 0.08206 L atm per K per mole. So how to find the density is using this formula and substitute all the information given into the formula and you will get the density is 0.62 gram per liter. Second question is a chemist has synthesized a greenish yellow compound of chlorine and oxygen and found that its density is 7.71 gram per liter at 36 degrees Celsius and 2.88 atm. Calculate the molar mass of the compound. Again, take out all the information from the question and we get the density is 7.71 gram per liter and the temperature is 36 degrees Celsius. We need to change it into Kelvin, so add 273.15 and we get it here. This answer 309.15 Kelvin. The pressure is 2.88 atm and R is constant gas, so the value is 0.08206. Using this formula, you can find the molar mass. So this is the final answer. Thank you.
Derive the ideal gas equation from the gas law. As we know, ideal gas actually is come from Boyle's law, Charles' law, Avogadro law. When we combine all of these three, we will get V is directly proportional to temperature and number of mole and inversely proportional to P. PV directly proportional to NT. So we will apply a proportionality constant, which is R constant, is a gas constant, and then we will get a ideal gas equation PV equal to nRT. Part 2 of this question, 0.112 gram sample of occupied, this volume and then this temperature and then 1 atm pressure. First of all, we must interpret the information given by the question. So volume must change to liter, temperature must change to Kelvin by adding 273 and then pressure 1 atm. If we want to find the relative molecular mass, we need to find out the number of mole first, because molar mass equal to mass over N. So N equal to PV over RT, substitute all the value and then we will get 2.4921 times 10 to the power of -3 mole of this sample. And then mass 0.112 gram divided by the number of mole that we get at early part, and then we get 44.94 gram per mole. This is molar mass. The question 1, relative molecular mass. So we need to cancel off the unit. So the answer is 44.94.
Hi everyone, my name is Farah from M1T1. I'm going to explain exercise 4 at lecture's note, page 49. Okay, in another experiment, 1.59 gram of zinc reacted with excess hydrochloric acid. The released hydrogen gas was collected using the water displacement method at temperature 23 Celsius using the water and pressure 99.99 kNm -2. The vapor pressure of water at this temperature is 2.81 kNm -2. Calculate the volume of the dry hydrogen gas collected. Okay, bila dah baca soalan, so kita boleh highlight mana yang penting. So kita highlight nombor yang dah dibagi, nilai yang dah dibagi dan highlight point yang penting. Jadi seperti madam yang madam telah ajar. Okay, pertama kita kena buat equation. Jadi dalam soalan tersebut dia akan bagi tahu Zn plus HCl, so akan dapat ZnCl2 plus dapat hasil hydrogen gas. So boleh seimbangkan, jadi akan dapatlah 1 mol dengan 2 mol of HCl. So boleh teruskan untuk kita kena tulis formula for PT sebab tajuk ni gas. So kita boleh tulis formula PT. And then kita identify. Okay, kita dah identify, so kita tulis satu-satu. P total adalah 99.99 kNm negative 2, pH2O 2.81 kNm negative 2. So nak dapatkan PO2 just tolak saja, so dapat 97.18 kNm negative 2. So the fourth step is find mole. Guna cara stoichiometry pun boleh bila, tapi kalau soalan dah bagi direct, so boleh isi je guna mole, mass and molar mass. Okay, and then dapat mole, and then guna formula PV and RT because water displacement. Jadi boleh masuk saja. Kenapa kena guna 8.314? Kerana ini. Okay, soalan bagi ini. Soalan bagi ini punya formula and ni Kelvin. So kita boleh guna 8.314. So boleh masukkan saja, and then kita akan dapat the volume. Okay.
Hi, today we want to discuss the question 5 in lecture note. And the keyword in the question is partial pressure. When you see the partial pressure, you must know this is Dalton's law. Dalton's law, the formula is like that: pressure total equal to PA plus PB. And PA is what? PS is PCO2 and PB is PN2. And how you find the PCO2 and PN2? You need the formula nRT divided by V. What is N? N is the mole. How you find the mole? And in the question, the mass of CO2 and the mass of nitrogen is given. So you just need to find the formula of mole and substitute into the formula, and you will find the mole of CO2 is 0.1 and mole of N2 is 0.0357. So just substitute the mole of CO2 into the formula like this, and this is constant. R is the constant value that you can find in the constant table. And the T you must in the question, T is given 27 degrees Celsius, but you must change it to the Kelvin, unit Kelvin. So you need to plus 273. So it will become 300 Kelvin. 300 Kelvin, and you just substitute in the formula, and you will get 1.2309 atm CO2, and substitute and get 0.4396 atm N2. And if you want to find the total pressure, you just sum up the PCO2 and PN2. That's all. Thanks for watching.
Exercise 6. Given total pressure for gas, methane 3.2 gram, 0.6 gram hydrogen, 11.2 gram nitrogen. Okay, 25 degrees Celsius is 2.2 atm. So first of all, we need to analyze the question first. Volume of the gas container. So we need to apply PV equal to nRT. Partial pressure, since we know the P total, here mostly we are using the mole fraction. So XA, okay. And then total number of molecules, so this one you need to times number of Avogadro. Okay, so first, volume of the gas container. We need to apply PV equal to nRT. P we know, V we not sure, N, okay, here we need to find out the N total. R, gas constant, T temperature, no problem. Okay, how to find out the N? So by applying the formula mass over molar mass. So mass of each gases divided the molar mass of each gases, we'll get 0.2 mole for methane, 0.3 for hydrogen, 0.4 for nitrogen. And then total number of mole is 0.9 mole. So apply formula PV and RT, we will get the V equal to 10 liter. Okay, next partial pressure, we are applying the formula PA equal to XA times P total. Okay, XA we can apply the formula NA over NT. So 0.2 over 0.9 times 2.2, so partial pressure for methane is 0.49 atm. Partial pressure for hydrogen is 0.73 atm, and then partial pressure for nitrogen gas is 0.98 atm. Always remember, must write down the unit. Okay, then total number of molecules, so the total number of mole is 0.9, so times number of Avogadro, we will get this answer 5.42 times 10 to the power of 23 molecule.
Assalamualaikum warahmatullahi wabarakatuh. My name is Alia from class M1T1. So this is the question that I've got, exercise 7 from lecture note. First, what is an ideal gas? Ideal gas is a hypothetical gas whose molecules occupy negligible space and have no interactions, and which consequently obeys the gas law exactly. Okay, next, dia tanya, determine whether Cl2 gas behaves as an ideal gas at this condition. So, maklumat yang dia bagi adalah mass of Cl2, volume, temperature and pressure. So, kita dapat tentukan menggunakan formula PV sama dengan N RT. So, kita boleh cari mol Cl2 dulu. So, kita masukkan je mass over molar mass. Mass 17.75 gram. Dan molar mass dia 35.5 darab 2 sebab Cl2. So, mol dia dapat 0.25 mol. So, kita masukkan je dalam formula tu. Dan jangan lupa tukar suhu darjah Celsius kepada Kelvin. So kat sini kita nampak yang nilai sebelah kiri dengan kanan tak sama. Ni bermaksud yang Cl2 disobey ideal gas.
State the condition when a gas deviates from an ideal behavior. The answer is at high pressure, at low temperature. At low temperature, the kinetic energy of the gas molecule decreases. So the gas particle moves slower and tend to hold them together. Now, the molecule have less energy to break away from their mutual repulsion. The intermolecular forces means the attractive or repulsive forces now become significant. While at high pressure, a gas is compressed, volume container decreases. Now the gas molecule occupies sizable portion of the container. Means the actual volume available for the gas particle to move about is always less than the volume of the container. So the distance between the molecule gas is closer. The intermolecular forces means the attractive and repulsion forces become significant.
Everyone, my name is Ahmad Zaidi. I'm going to present my question, which is question 8. The first thing you need to do is read the question and highlight the objective of the question. After that, we need to list down all the information that is given from question 8. After that, we need to find the pressure of O2, which is we're going to use the Avogadro law and substitute the value and find the pressure of O2. Then we need to use the stoichiometry method. We change the unit from mmHg to atm. Then to find the mole of O2, we need to find the mole of Ag2O first, and using the same stoichiometric method we can find the mole of O2. After that, we need to find the volume of the oxygen in liter, and from this formula we need to substitute all the value that we have got from the upper equation, and that's the answer. That's all from me. Thank you.
Hope you all learned something. Thank you.